Catalysts and enzymes. The rock on the edge of a cliff is an unstable system. An unstable system can stay that way for a long time, until someone gives it a push. That push is the activation energy needed to start the release of energy. Sometimes just a little push is needed, like in the case of this ball on a flat surface. Sometimes a bigger push is needed, like in this case. In both cases, the energy released will be the same because the ball falls the same distance. The activation energy is different. Catalysts speed up chemical reactions. They do this by lowering the activation energy of the reaction. Less energy is needed to start the reaction, so it happens more quickly. The catalyst remains unchanged. The initial and final energy of the reactants and products is not changed by the catalyst. Catalysts work by decreasing the activation energy. Just as a rock cannot quickly be pushed over a hill, a reaction cannot quickly occur unless the molecules possess sufficient energy, the activation energy. If the height of the hill were lower, the person could roll the stones over the hill at a faster rate. Catalysts speed up reactions by reducing the activation energy for the reaction. Platinum, or PT, is an example of a catalyst. Cars make carbon monoxide, a toxic gas. Platinum, in catalytic converters, catalyzes this chemical reaction, turning carbon monoxide into carbon dioxide, a non-toxic gas. This reaction would not happen quickly without the platinum. However, the platinum is unchanged by the reaction. Life requires energy. Living things take in energy, transform it, and release it. This is accomplished by chemical reactions. Chemical reactions in living things need to be very fast. Enzymes are catalysts made by living things. They are almost always proteins. All cellular life uses enzymes to speed up chemical reactions. Enzymes lower activation energies and speed up chemical reactions in living things. Enzymes increase the speed of a reaction by decreasing the activation energy of the reaction. The energy of the reactants and the products is the same, but the activation energy is lowered by the enzyme. Amylase is an example of an enzyme. Potatoes are starchy. Starch is made of many sugar molecules which are bound together. When you chew a potato, a saliva enzyme called amylase breaks down the starch into smaller sugar molecules called maltose. It's part of digestion. Your body makes amylase. It would take years to break down starch without amylase. Here are two reactions that feature a different enzyme, catalase. Click here for a video example.